Okay. Several of you knuckleheads need to get busy on your homeworks. Put down several N's last night. So we need to get on top of that. I know that there's been a lot of school activities going on. A lot of that stopped or slowed down at least now. So you guys, let's get on top of those homeworks and get them uploaded and do what we're supposed to do on your end. Quizzes Friday, retakes. Make sure you get those done if you wish to retake that thing. At some point, I'll release it and so that you can see what you did wrong. But if you got questions about that, always ask. Right? Just ask. I know the highest question missed was the one that you had to rewrite it. Find the drawing a blank. Sorry. Inverse of when you had to factor the y out. There's a reason for those questions. And a lot of you guys, I put notes on your homework because you didn't do a very good job on your homework question on that, which in turn resulted in a bad result on the test question or quiz question. Okay? So, I mean, almost every question comes from homework in some way, some form, some fashion. And the harder it is on homework, the better chance it is on the test. Quiz. Okay? 2.11. That was assigned to you on Friday. Whopping 2 pages. What questions you got over that? Anything? I know I'm starting to not post answers because I'm getting the feeling that you guys are using answers just to write your answers, to write your stuff. Of course, you can find them all over the internet anyway. So I really can't keep you from doing that. But I mean, if the 3 points is that big of a deal to you, those 3 points turn into 100 points at some point, right? I don't care if you get these right or wrong or indifferent. I'm just looking to make sure you're doing them right. And last night I got froggy and started writing some of your notes because I realized some of you guys are not doing right you're supposed to do on your homework. So let's do better jobs on those, especially when they're light homework assignments like this. Anything about these? In behaviors, you got to know the in behaviors of logs. You got to know what logs look like. You got to know what logs look like. They start at 0 and go off to the right, or they start at 0 and come down to the right, unless if it's shifted left or right. But everything else is shifted up or down, which you really can't tell. It's dilated, which you really can't tell. Because they shoot out so fast and they go up so fast, it's hard to tell dilations. It's hard to tell ups and downs. It's hard to tell dilations vertically and hard to tell dilations horizontally, and it's hard to tell shifts horizontally. Vertically, I keep saying horizontal it is because that changes the asymptote. Just like exponential grows and decays. It's really hard to tell all those things except vertical shifts because it shifts that asymptote. So you need to understand all that stuff, right? Concave up, concave down, so it's always decreasing rate. That's an increasing rate. Multiple choices, make sure you know those. Limit statements, get comfortable with those. You got to understand these graphs and how they work. Okay? If you ever come across a question, right, you're thinking, gosh, I'm not too sure how to do this. Either figure it out online or send me an email. I don't care. Send me an email. I am confused about this. That's what I'm for. Most of the time, I'm pretty good at answering those fairly quickly. Okay, here we go. 212. Just to kind of lay this out, right? Lay this. Make sure we all on the same page, right? Keep up with this calendar. Whoa. Keep up with the calendar and what you have going on in class, right? It will always tell you and show you what we have going on. So 212 today. So fairly decent lesson. I'll probably talk more than I need to, but again, I want to make sure I cover things. And then we're going to hit 213. For this Friday's a B day. And so then we're going to eat some turkey. So you got a long time to forget all this stuff, right? December. This is so because we end on a B day, that's like an extra B day to line things up. And a teacher, we didn't want to teach 214 and then have them forget 214 over the entire break. And then we probably will go 214 here, is my guess. And then that would put 215 here, and then I would have 2 review days. But we may review here and then do 14, 15. I'm not too sure. We'll kind of play that by ear, but then kind of just see how that's going. But either way, that needs to be highlighted. That's your exam. Okay, that's your exam. Your last exams, last page I got done. So I decided to hook up on your homework instead of finishing your exams last night. I'll finish those during 5th hour today. No, 5th hour today? 3rd hour today. 2nd hour today. Jiminy Christmas. Who knows? This is 0A. I've never had a 0A before, and it's really messed with my head all year long. In the 1st hour, 2nd hour is my prep hour. So I'm shutting my door and I'm finishing y'all's exams. Okay? And so then I'll put those in. The other teachers are done, so we'll figure out how we need to adjust those. Hopefully, I told you guys, I want you guys to set it. Quit asking for it and just set it. If you get hundreds, you don't have to worry about a curve. This is B, this is B. This is your final exam review day to find out if you're exempt or not, or what we need to do to tidy this up. And then finals are one of these days. They're set. They came out in the announcements. I'll put down what day your final is. 0A. But typically they're here. I think it's here. It is. I think this is 0A, 1, 2, 1, 3, 4. And that's where the second happens. That's my prep. I may be sick that day. Woo! All right, here we go. 12. Keep up with, like I said, keep up with what's going on, what you need, and what you need from me, but what you got to do for me, more important than maybe what you need from me. Okay, this one, this one ranks up there difficulty-wise. Mostly because you guys got introduced to logs last year, but y'all didn't do a whole lot with them compared to what we're going to do with them this year. So I think this is difficult to me. Maybe not to you guys, I don't know. Since logarithms are expressions that can be also written as exponential form, the same properties that apply to exponents apply to logs. I don't think this is difficult. This is what's not new to you. These properties allow us to manipulate logarithmic expressions from equivalent expressions that may be useful when solving equations or graphing functions involved with logarithms. So there are 3 properties that you need to make sure that you know about logarithms. And hopefully you know these already. I'm sure you were introduced to them at some point. This is log any base. Doesn't matter what the base is. So that's why they put base B. And they're multiplying xy. Now recognize that first, because that's one of the little tricks they're trying to notice, that xy is in parentheses. Okay, that is different than log base B of x times y. Y'all with me on that? That y is all by itself. It doesn't have a log with it. So this only separates or becomes 2 if they're both being taken to the log. And those are the little bitty things you got to make sure you recognize. We get in such a habit of just seeing log base B of x times y, and we want to split that up. You can only split it up if both of those have the log. You kind of are distributing that log B to both, but you're really not, because there's not a plus sign between it. But just little bitty things you got to recognize that you probably didn't recognize last year. Example, log base 2 of 5x. You can change that into log base 2 of 5 plus the log base 2 of x. The base stays the same. You don't change the base. We'll talk about that in just a little bit. This one is division. And so we understand division changes into subtraction. Again, make sure you're taking the division of both of those. That one's normally understood. And then the power property, log base b of x to the n. Now notice only the x is to the n. That's different than, let me do it this way. Let me do it this way. Blank white screen, blank white screen. There you go. And make this stupid thing. Come on, there you go, show it. Here we go, rider. Yay, y'all kind of see that? This one, only the x is to the n power. This is the one that you can change into n log of x. You can do that here. There you can't. There you can't. That's completely different type deal. Okay? So just please recognize those type things. They'll do little bitty things that might mess you up. Okay? All right, here we go. These properties can be used to show various transformations of logarithmic functions and can be written in equivalent ways. And that's what's going to be new to you more than rewriting it. Last year in Algebra 2, you guys got this, said rewrite it or expand this, right? Or condense this. Those were your problems that you had, expand or condense. This year, we're going to rewrite them to where it simplifies easier, it looks better, it just looks like a better function than something else. Okay, example number 1. For each of the following, write an equivalent expression by condensing each expression to a single logarithm. This is what you guys did in Algebra 2. This shouldn't be that new to you, okay? Log base 4 of x plus log base 4 of y. You can change that into log base 4 xy. Again, put those in parentheses, little bitty things like that. Okay, you may or may not have put those in parentheses. They may or may not have emphasized that. But now we need to. Okay, log base 3, 5, log base 3z, and there's a minus sign, so I can combine that into log base 3, 5 over z. That really should be in parentheses. However, the fractions are sometimes, that's understood that they're, here, let me show you what I mean by that. That one you can get by without doing parentheses. Everybody understands that I'm taking the log of both of those rather than this. Right? That one I'm not taking the log of both of them. So that's why we really don't have to put parentheses on this one, whereas the multiplication you kind of do. But that's also why they don't write it like if it was log base times y, that they'll put the y in front of it. That's why they do that, so that nobody gets confused on what I'm taking the log of. This one is not too sure what we're taking the log of. Now we know we're taking the log of both x and y. Okay, I'm just a little stickler for these type of things just because I don't want you guys to mess up on something that seems so easy, but it's, I hope y'all follow what I'm saying when I do all that. This is the one that you guys will start messing up on because we got a subtraction problem and then a subtraction problem with no parentheses. So this is going to be 1 log base 10. Y'all are okay with me not writing the 10, good? You don't have to write 10s. And then this is x over 5, but then it's over z. And nobody wants a fraction with a fraction with a fraction. So this ends up being, this z is over 1, and we flip and multiply it. So this actually ends up being log of x over 5z. Because you got to, anytime you have a division divided by, right? A fraction divided by a fraction means a fraction times the flip of the fraction. Right? You guys learned that a long time ago. When you divide fractions, you invert and multiply, or you flip and multiply. So you flip this thing. So the 1 goes up with the x and the z stays down with the 5. Okay? Here we go. This one here, that 3 becomes an exponent. So this is log base 2. We have x cubed over y. And again, that one you can put parentheses or you don't have to put parentheses. That one, letter C, you can put parentheses. You don't have to put parentheses. You really need to put parentheses on A. Yuck. So immediately I'm going to put this 2 with this A, make it squared. I'm going to put that 5 with that B and make it to the 5th. Log base 7. A squared. A lot of kids mess this one up too. This one's bad. B to the 5th. And then it's plus the 4, which means multiply by the 4. That means it puts the 4 up top. Because it's not, that's, I hate to do this. Let me do it. I'll do it and then I can't do undo, I don't think. That is different than that. Y'all with me? In that particular problem, the 4 would stay on the bottom because the whole thing's being subtracted, meaning the whole thing ends up being divided. But that's not what we have. We don't have those fractions or those parentheses. So it's A divided by B, but then that whole fraction is times 4. And so the times 4 would put the 4 up top and really, sorry, in blue, that would really put the 4 in front of the A squared. It's not wrong to put A squared 4, that just looks silly. Oh, thank you. Hello, how are you today? Good, how are you? I am loving life. Are your desk out in the hallway or we have extra ones? This one. This one right here is what we call separating the adults from the children. You didn't see one like this last year. I bet. If you did, man, that's cool. Delete. I don't think I have enough room. 2 plus log base 6 of 4 x. That's what I said. I'm supposed to combine this. And that is not log base 6 of 2x or x2, right? You can't change that to multiplication because this doesn't have a log. This doesn't have a log. Boy, they're going to do some tricky stuff on this. What lesson was that where we said simplify this, and you had a whole bunch of those, like you had to tell me like log base 10 of 10 was 1, right? Log base 10 of 100 was 2. Log base 2 of 4 was 2. Log base 2 of 8 was 3. Y'all remember doing all those things? This one's already simplified. You got to undo that. And because that's log base 6, I've got to make this log base 6 of 36. Why in the heck would I do that? So that I can combine them. Because right now you can't combine them. The only way to combine them is you got to have a log and a log. Now, is that simpler than what we had? I don't know. But they said combine it. And so if they said combine it, that's what I got to do. And so this 2 is the same thing as log base 6 of 36. I could write this 2 a bunch of different ways. I mean, there's infinite ways I can write that 2. I could write it the square root of 4 if I wanted to, but that doesn't help me combine it. I could write it log base 2 of 4, but that doesn't help me because I can't combine that. The only way to combine it is if this is a log 6 and this is a log 6, and for this to be a log base 6, this has to be a 36 because log base 6 of 36 is 2. And now I have plus log base 6 of x. And now I can combine those stupid things just like I did in letter A. because this is now log base 6 of 36x. And again, officially, you should put parentheses around the 36x. Wow. I'm telling you. That's a big deal. That tells me when you can do stuff like this, guys, you start to understand logs and what they're doing. When you can do things like this, like, I mean, who would look at that 2 and want to make it log base 6 of 36? I mean, nobody would want to do that. But if they're combining it, I have to do that. I mean, why would I make 2 the square root of 4? I wouldn't ever do that unless if I needed a square root to combine it with. Okay? All right, beautiful. You'll have some on your homework that you'll need to practice with like that. So let me do that. This is log base 6 of 36 plus log base 6 of x, and now it becomes the log base 6 of 36x. Beautiful. Example number 2, they're going to give you a multiple choice to practice on. Again, a lot of times, guys, on your homeworks, do yourself a favor, not necessarily figure out which one's right, but figure out why the other 3 are wrong. That will help. I mean, I know it's homework. You should care less about which one's right. Just care about why it's right or why the other ones are not. Those are the type of things you really need to do in your homeworks. Log base 3 x squared y. So you might just expand that out mentally in your head without looking at it. This could be log base 3 x squared. I bet is what they want to do. I don't know if that's what they want me to do or not, but I'll look at my answers. Then that division becomes a minus, and then I have log base 3 of y. And I look at that, and that looks just like letter C. And so letter C is correct. Now, again, let's look at A really quickly, just to make sure you can combine that. This would be log base 3 2x over y. I don't have 2x over y. I got x squared over y. So that's what makes this one wrong. This would make what? Both x and y squared. That would make them both squared, and only the x is squared. So again, that's kind of how you should do these homework questions. Not necessarily look to see which one's right, look to see why the other ones are wrong, or look to see what it makes. That's like 3 other practice questions. Log base 3 of x plus log, so this would be just like this one. This and this are the same answer, because this becomes 2x, and that's what that is. And then you have the minus log base y. So this and this are the same thing. Again, if you can recognize those type of things, if this and this are the same thing, you know that's the wrong answer, because there's no way that 2 of the same could be the right answer. There's only one correct multiple choice. All right, here we go. Example number 3. I got the function f of x is equal to log 6 of x. It has a horizontal dilation. Well, I kind of knew that already, because the 6 is with the x, and anything with the x is a horizontal, and it's a dilation by a factor of 1/6. Remember, opposite of what you think with the x. Of the function g of x equals log of x. Show that f can also be written as a vertical translation of g. With f of x equaling g of x plus k, and k is that constant, that is going to be the vertical translation. So again, we're separating, this is tougher, okay? So right now, I hope you all know that has to be a horizontal dilation by a factor of 1/6. That's what that is. It tells me that it's a horizontal dilation. It tells me that it can also be a vertical translation if I rewrite it. So that's what they want me to do. Well, I know this for a fact. I can split this up into log of 6 plus log of x. And what do we know log of x is? G of x. Log of x is g of x. So now f of x is equal to g of x plus log 6. And now I have a vertical translation of this function as opposed to a horizontal dilation. And the vertical translation is up log 6. How much is log 6? I don't know. Point something. How do you know it's point something? Because 10 to what is 6? Well, I don't know, but 10 to 1 is 10, and 10 to 0 is 1. So it's got to be point something. Those are the type of things you kind of need. If I don't have a calculator, you should at least know that this is point something. It's just a number. It's not a good number. It's a nasty number, but it is just a number. Log 6, that's just a number. Log 6, boom, point something. Okay, beautiful. Change of base property. You may or may not have used change of base formula. A lot of times we don't use it that much anymore because our calculators have a change of base. Back in my day, we didn't have a change of base button. All we had was log 10. We had two bases. We had base 10 and base E. Those are the only calculator functions we had. We didn't have the change of base. So we had to use the change of base formula whenever the base was not 10 or E. Here's what the change of base says. Log base B, or log base anything, of x. It is the log base A, normally 10 or E, of the x over the log of A base B. So you're changing the base from B to A. Of course, A has to be greater than 0. A cannot be 1. You can't change the base to 1 because log base 1 of anything is 1. So this property illustrates that all logarithmic functions are vertical dilations of each other. They're vertical dilations of each other. Let me show you guys this too. A lot of students mess this up. This is an uh-oh that a lot of students mess up. No. No. Okay? That is different than what we said earlier of that. Okay? This goes to this. This does not. And goodness gracious, don't cancel log base 10 out. Please don't do that. I'm showing you all these things that I don't want you to do because you guys are too smart to do stupid stuff like this. That's for the camera. All right, so here we go. Example number 4. F of x equals log base 4 of x. G of x is log base 9 of x. Show that f is a vertical dilation of g by finding the value of k, such that f of x is equal to k g of x. Well, right now, I know that f of x is equal to log 4 of x. And I know g of x is log base 9, and this is log base 4. So I need to change the base to base 9. So this is equal to log 9x over log 9, 4. Y'all okay with that? What do we know log base 9 of x is? Log base 9 of x is g of x. Log 9 4. Change of base. You don't like my 9? Oh, y'all see some of the chicken scratch you guys, right? This is a 4. It's okay. Sorry, good questions. Sorry. I need to write slower and it would show up a little better. I do blame some of this on the electronic. Just some of it. Or so the vertical, sorry, I almost said translation. The vertical dilation is by a factor of 1 over log base 9 of 4. That's one of those type of questions that when you read it looks pretty hard, but it's not that really hard when you know the change of base formula. Why did I change it to base 9? Because this was base 4 and this is base 9. And they wanted to show that f of x is a translation of g of x. So I had to get f of x to look like g of x somehow. So I just changed it to log base 9 of x over log base 9 of 4. And log base 9 of x is simply g of x, and I'm substituting in. Talk to me. Where'd I get the 4 from log base 9 of 4? That's the change of base formula. It's okay. I get it. Log base b of x is log base a of x over log base a of b. So this x, this x goes here, this b goes here. Okay? So the x stays on top, the 4 has to go here. So this 4 goes here, this x goes here. And then I can change it to any base I want. But I decided 9 because they wanted the 9 here. I know. It's a little, once you see it, it's like, how did I not see it? But if you don't see it, then you don't see it and you need to see it. Yay, yay, yay. Whoop, whoop. Okay, click. Natural logarithm is base E. Base E. I think you guys know that already. So anytime you see the log with a base of E, whatever, that's equal to the natural log. And a lot of times mathematicians use that. Why? Because we're lazy. And that's 2 letters as opposed to 4 letters. Ln is 2, log base E is 4. Which of the following expressions is equivalent to 3 ln x minus 4 ln y? And this would make ln x cubed. This would make ln y to the 4th. And you would have x cubed over y to the 4th. And this one is x cubed over y to the 4th. This one would make it ln of 3 plus ln of x minus parentheses ln of 3 plus ln of x minus ln of 4 plus ln of y. And that's nowhere close to what we started with. Letter C, I wouldn't even know what it changed to. Yucky. Same with letter D. Is that it? That's it? Is there anything else on 12? Like if you turn the page, it says 13. Okay.